Assalamualaikum and a very good evening to Dr. Asmat binti Ismail and my fellow friends. My name is Sazman Iskandar bin Abdullah and this is our group assignment for BCT533 Environmental Green Studies. This presentation is to explain in detail of our passive design strategies. We would like to introduce you about the passive design and passive cooling. Firstly, the passive design. A passive design that makes the most of the surrounding environment to generate a comfortable atmosphere for the building occupants. Along with minimizing energy use, implement a renewable energy system that meets household energy needs. In order to create buildings that are energy efficient, passive design solutions take into account the sun, wind, light, and microlimit in this area. The arrangement is made early on in the construction process to fully utilize the plan section, material choice, and location, which have a greater impact on the building energy use. This also means that passive architecture fully utilizes filter indirect glare-free daylight while excluding the need for the building's mechanical or electrical system. The sun and cooling breeze are two examples of the natural heating and cooling system that used in the passive design. Next is passive cooling. To put it simply, passive cooling refers to utilization of design choice to reduce heat absorption while enhancing heat loss. Our level of comfort can be raised while using less energy thanks to passive cooling. Following the concept of passive cooling design is crucial when building or buying a home. Whether or not to include air conditioning is the most crucial choice to make. There may be significant structural change required in some climates to incorporate air conditioning later to meet needs of household cooling, ventilation, and lighting. Passive cooling use free renewable energy sources like the sun and wind. Along with that, mechanical cooling is no longer necessary. The building becomes more comfortable and energy efficient thanks to passive cooling, which also enhance the quality of the air inside the structure.
Assalamualaikum, my name is SYAFIQAH binti ZAZULI and today I will present to you about the case study building that I have been chosen for this research. The building that has been used in this case study is one-story building located at Surau Complex Sukan DR.ASMAT Iskandar Perak. The building is a multipurpose building which is divided into three areas, which the first one is men's prayer room, women's prayer room, and the last one is equipment store. The chosen building has been occupied for 4 years, and this case study will be focusing on the passive design strategies that have been applied to the building. The founding will be discussed whether the building complies with the passive design properties or not. As you can see here is a case study building that has been used in this research. Now let's move on to the building orientation. One of the components of passive design is a building orientation, which needs to be chosen before the building is constructed. The general rule for the best orientation of the building is to avoid facade with most opening facing east or west. Building orientation matters because it has an impact on the geometry of the structure, the placement of openings, ceilings, and other aspects of natural illumination. From the research of this study, the facade of the building is faced south, which follow the passive design rules of building orientation. Next is natural ventilation. In the case study building, a casement window and top hung window is used in those rooms. Total of 8 wall openings are used as a natural ventilation for this building, consisting of 4 casement windows and 4 top hung windows. This window and opening does not provide enough ventilation because in this building there are 3 partitions, and only two partitions get enough ventilation, while the middle one does not get good enough ventilation. The main wall opening for those areas is the window. Two single-leaf casement tinted glass window with aluminium frame and two double-leaf top-hung glass window are used in the men's prayer room. This casement tinted glass window and top-hung glass window are able to allow air from outside to come in. Meanwhile, in the women's prayer room, only two double-leaf top-hung glass windows are used, as opening from the upper side is the way to open hanging window. It makes the air in the room naturally circulate with nature and the air in the room is fresh. This building also used two double-leaf casement tinted glass window with aluminium frame in the equipment store. It used to allow a huge amount of fresh air to enter the building and push polluted air out of the building compared with the other opening in both rooms. Next is the natural lighting. This study area does not have enough natural lighting due to several factors. There are a lot of obstacles in the area of the case study. This building is between complex sukan and toilet, so it does not get enough natural lighting during the day. The only resources of lighting for the building are casement window and top hung. Both casement window and top hung at the men's prayer room and equipment store were tinted, which reduced more natural lighting into the building.
I will explain about the roof that has been used in this case study building. In order to keep your energy costs as low as possible, a building roof is crucial for insulation. Every component of the roofing serves as a defense against the elements. By restricting air from entering or leaving the structure, they can help keep a room warm in the winter and cool in the summer. In this case study building, the type of roof used is zinc roof. In addition to having exceptional corrosion resistance, a zinc roof has other benefits over other roof types. Because zinc roofing is self-healing, it can cure itself if it gets scratched with enough time. Its maintenance requirements are minimal. It can install and essentially be forgotten about, even at a difficult environment exposed to wind and spray. The roof used in the case study building is with eco-friendly characteristics. Zinc is a green building material. Since zinc has a lower melting point than other metals, its manufacture requires less energy. Additionally, because zinc is completely recyclable, replacing a zinc roof generates no waste. Furthermore, we will go to the building facade part. Facade can refer to any predominantly vertical face of a building envelope, such as an external wall. For this building, there are no specific off-building facade. This is due to the structure's simple nature as a sport building, which is made up of the surau and a sports store. The sports store is on the left side of the building, while the surau is on the right side of the structure. In addition, this structure is situated in the middle of the public restroom and the badminton court at the UiTM Perak Sports Complex, which is Sri Iskandar campus. As a result, it lacks a specific facade. Last but not least, this is our last part of our case study building, which is the landscaping. From the observation, this case study does not provide a proper landscaping. Around the case study region, so few plants were planted. There is only one tree planted on the right side of the building, where it is quite far from the building. Furthermore, for the surrounding area in the case study, it is surrounded by the grass. This is because the building is close to the field area and has only a small floor area where it is only covered by the cement floor. The building is located in an open area, and this causes the building to receive a large amount of sunlight, especially during the peak hour, which is at noon. That's all from me. So we will go further about how the existing passive design reduce the cooling load based on the Malaysian standard.
Okay, next is how the existing passive design reduce the cooling load based on Malaysia standard. Firstly is building orientation. The orientation of a structure refers to how it is positioned in relation to the course taken by the sun during the year and to the predominant wind directions. Passive design also considers how living and sleeping rooms are planned and situated, either to benefit from the light and wind or to be shielded from their impacts. Passive cooling orientation ensure access to cooling breezes while blocking out undesirable sun and hot winds. In the majority of climates, passive cooling is necessary. Orientation should typically avoid direct sunshine and radiant heat from surrounding structures at all times of the year in hot, humid climates without chilly winters while maximizing access to cooling breeze. Be aware that some areas in the climate zones will still gain from access to the sun during winter. Next is natural ventilation. Natural ventilation is the use of wind and thermal buoyancy to generate air movement into and out of your home without the use of mechanical system with the aim of bringing fresh air into your home. Natural ventilation can provide free cooling and lower your home's energy use at night throughout the summer. Natural ventilation in buildings can often be divided into two categories: air pressure ventilation, also known as wind force, and stack effect ventilation, also known as thermal force. The horizontal air movement that occurs when air flows into a structure as a result of the difference in air pressure between the inside and external environment is known as air pressure ventilation. Since the air inside is significantly warmer, the cold air will flow through the windows, door, or building claddings into the room. Next is natural lighting, commonly referred to as daylighting. It's a strategy that effectively brings natural light into your home through outside glass such as windows, skylights, minimizing the needs for artificial lighting and saving energy. The position of interior partition, window sizes and spacing, glass choice, reflectance of interior finishes, and the window size are all need to be taken into account. Moreover, there are numerous distinct kinds of daylight fixtures and each one has a special set of design consideration. A successful daylighting design will maximize the amount of daylight that enters the structure while also improving the occupant's experience of the luminous environment. It's not only about increasing light levels when designing for daylighting. The occupant of a space can feel very uncomfortable when there is much sunshine present. Control, not just of light levels, but also of the direction and distribution of light, is the important concept in daylighting design.
Next, let's we move on with the roof. A roof is the top covering of a building, including all materials and constructions necessary to support it on the walls of the building or on uprights. Based on the case study, the building used flat roof for the roof structure. The roofing materials used is zinc because it is low maintenance. Aside from ensuring the roof is free from fallen debris such as leaves, little upkeep is required. Zinc is 100% recyclable and environmentally friendly. Other than that, zinc takes less energy to produce other than metal roofing solutions because of its lower melting point. Next, building facade. A facade refers to one side and usually the front of a building. It is an integral piece to the overall design of a building. Based on the case study, the facade of this building consists of two single-leaf glass tinted casement windows. The facade receives minimum sun radiation because the orientation of the building is oriented towards south, which is far from rotation light. Certain lights provide warm, ambient light throughout the day and generally feel sunny and comfortable. Next, let we move on with the landscaping. A landscape is the visible features of an area of land, its landform, and how they integrate with natural or man-made features, often considered in terms of their aesthetic appeal. Based on the case study, there is a lot of landscape in the area around the case study building. This is because this building has a large area of land around it. The surrounding area of the building is large to plant several trees or other plants. Other than that, this case study building get the natural landscaping from the tree. And the last, conclusion and recommendation. In conclusion, all significant features of a building must be designed passively to either avoid or resist the accommodation of solar heat. The passive design is influenced by the local climate conditions and should be planned accordingly. Based on this study, we recommend conducting a case study properly, such as by employing a large meter instrument to accurately measure illumination. Furthermore, when compared to using a large meter application, this large meter will provide a more precise reading. Good landscaping, on the other hand, can help to limit the amount of the light that enters the house directly. That's all from us. Thank you.